Okay, good morning class. At this point we're looking at analytical geometry, chapter 4. Also at this point I gave you for homework the 4.1 to do. So at this point you guys have done 4.1 already, so I'm going to go through some of the equations that was dealt with in grade 10. Okay. So we are reading from the example or the explanation on page. Which page are we on? I think we're on 90 something. 80. 80. 81. Okay. So analytical geometry, chapter 4 out of the Keeping Math Simple textbook. Right, we're going to look at the revision quickly. In this lesson, we will only be looking at the revision of grade 10. Okay. In grade 10, you learned about the formula for. In the first case, you learned about distance between 2 points. And how do we calculate the distance? Using the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Not so hard. Then we spoke about the midpoint of a line segment. How do you calculate the midpoint? x1 plus x2 over 2, y1 plus y2 over 2. Then we spoke about the gradient. How do you calculate the gradient of a line? y2 minus y1 over x2 minus x1. Also at this point we know that it could be written as y1 minus y2 over x1 minus x2. However, if y2 is first in your numerator, x2 must be first in your denominator. Likewise, if y1 is first in your numerator, then x1 must be first in your denominator. Which means to say that coordinates of that point must be considered first in both cases. Okay. Let's revise these formulas briefly. Given the point P, which is right in the Cartesian plane, we used x1, x2, y1, y2. Not so the same. Okay, but if you that kind of girl want to use a P and a Q, by all means you may do so. Okay. The distance between, we spoke about that now. We spoke about the midpoint, and we spoke about the gradient of the line. Okay. Application of the basic formulas. Are we still on the first page? 81. Okay. So application of the basic formulae. Let's go with the first example. Example 1. We are told if P, which is 4 and 8, O, which is 0 and 0 and R, negative 1 and 4 are the vertices of triangle POR. Prove that is an isosceles triangle. So people, what do we know about an isosceles triangle? What does isosceles mean? Two sides are equal, not so. So that's 4 and 8. I'm just going to give you a visual representation of what's happening. At 0, okay, this the diagram, just not drawn to scale. So 4 would have been there, 8 is approximately there. Let me move this over. 0 and 0, and R is negative 4 and 4. Okay. So we said that this is, if this is an isosceles triangle, what's the properties of an isosceles triangle? Two sides are equal or two angles are equal. Not so. But since at this point we have dealt with distance formula, we're going to work out the size. Okay. So let's work out the size of OR, the length of OR. How do you work out length? Distance formula. So it's x2 minus x1 squared plus y2 minus y1 squared. So if you go OR, so it's going to give you the square root of negative 4 minus 0 squared plus 4 minus 0 squared. Okay? Which is going to give me 1632. So it's 4 root. Okay? Don't make a mistake. The square root of 16 plus 16 is 4 root 2. What's wrong? Okay. So that is going to be 4 root 2. So let's work out OP. So if OP also works out to be 4 root 2, the job is done. I don't go with the third side. Okay? However, if it's anything other than that, then I'm going to work out the third side. Okay? So again, distance formula for OP. So O is 0 and 0. P, make it a habit of writing this on the side. So I know some of you mix up the coordinates. So if this is x1, y1, that is x2, y2. Not so. So we go x2, which is 0 minus 4 squared plus 0 minus 8 squared. Okay, this is not the one that you're looking for. So that's the square root of 4 squared, which is 16, plus 8 squared, which is 64. Gives you 4 root 5. So is it equal? No. So that is 4 root 5. Let's go then with RP. Distance RP. How do you calculate the distance? Distance formula again. So it's going to be R, which is negative 4 and 4. So we go for R and P. It's going to be, if that is x1, y1, this will be x2, y2. Not so. So I say negative 4 minus 4 squared plus 4 minus 8 squared. Put that in the calculator. That is the square root of negative 8 squared plus negative 4 squared. Or you can put it in as the square root of negative 4 minus 4 all squared plus as it is there. Okay? That gives us 4 root 5. What do we notice now? What do we notice? These two are equal now, not so?
Yes.
So how do we conclude? We say since, we state the obvious, RP is equal to OP, which is equal to 4 root 5. Therefore, triangle OP R is an isosceles triangle. Why? We got two sides. Okay. Right, people, let's look at example 2. Example 2 is on page, also on 81. Okay. Example 2 on page 81. Here we are told that triangle ABC is a right angle triangle at B. We are told that A, which is negative 3 and 9, B is 5 and 3, C is negative 1 and negative 5, are the vertices. Vertices means the vertex, no? The end points of the triangle. Determine the area of using analytical methods. Analytical methods, whenever they say that you must use distance formula, gradients, or midpoint. That is what you must use. Okay. So to calculate the area of this triangle, how do you calculate the area of a triangle? Half base times perpendicular. Not so. So if that is your base, then that is your perpendicular. Not so. So in other words, I need to calculate the length of CB, that thing on top means length, and the length of AB. You all agree with that? So again, distance formula, we're using it first, we write it down. X first time, x2 minus x1 squared plus y2 minus y1 squared. Okay? So for C, it is negative 1 and negative 5. And B, am I moving too fast? 5 and 3. Okay, so then no, it's fine. So this is x1, y1, x2, y2. So it's going to be 3, no, x1, x2, so x2 is going to be 5 minus 1 squared plus 3 minus 5 squared. Okay, so that gives us the square root of 6 squared plus 8 squared. Gives you 10. Gives you an answer of 10. So this length is 10. The perpendicular height, which is AB, same distance formula. So A is going to be negative 3 and 9. B is 5 and 3. So I make that x1, y1, x2, y2. Okay, so that the examiner know which points I'm using where. And also a guide for myself. Okay? So it's going to be x2. It's not going to make a difference in this case, no? Because it's being squared. 3 minus 9. But when it comes to gradients and midpoints, okay, it doesn't make a difference in midpoint as well. But the gradient is where the learner normally misses it out. Okay? So it will be 3 plus 5 is 8, so it's 8 squared plus 6 squared, or negative 6 squared. It's also 10. Can you see that, people? So therefore the area is equal to half my base, which is 10, times my perpendicular height is also 10, which is 50 units squared. Is that correct? Somebody just follow there to make sure that we're on the right track. Okay.
Yes, sir.
Okay, so let's look at example 3, the midpoint formula. The midpoint formula, that's example 1 on page 82. So example 1 on page 82, the midpoint, we are told that calculate the coordinates of M, the midpoint of line segment. So we start off by saying the formula. So for the midpoint is going to be x1 plus x2 over 2, y1 plus y2 over 2. So if that is your P, which is negative 3 and 8, and Q is 9 and 1, M is the midpoint. So if that is x1, y1, this will be x2, y2. So the gradient, and so M is the midpoint. It's going to give you negative 3 plus 9 over 2 and 8 plus 1 over 2, which gives me my midpoint to be 6 over 2, which is 3, and 9 over 2, or 4.5 or 4.5. You all okay with that? Okay. Example 2. Example 2 is a bit different. Here the midpoint is given. Can you see that, people? Are we still on the same page? Yes? Okay. So, 3. Okay. So here, if M, which is 7 and negative 4, is the midpoint of line segment PQ, where P is negative 3 and 6, determine the coordinates of Q. Now, we said this one's a bit different, as the midpoint is given. Okay. So again, we write down the formula. So the midpoint is going to give you x1 plus x2 over 2 and y1 plus y2 over 2. Once this is worked out, we actually get the x mid and the y mid. Not so. Which now means to say that x1, if you go now with q, which is negative 3 and 6, p, which is x and y. So if that is x1, y1, this is x2, y2. Remember, we use the end points of the line segment you are referring to. Okay, we're using it. So if we go x1, which is negative 3, plus x2, which is x over 2, and that's going to give me my x midpoint. What's the coordinate of the x midpoint? 7. Can you see that? That's 7 over 1. Or, the other end, it's actually colon. y1, which is y1, 6 plus y over 2 is equal to negative 4, yeah, which is the midpoint thing. Can you see that, people? From here, this is a method of solving for x and y. Cross multiply. So negative 3 plus x equal to 14. So x equal to 17. On the side here, we cross multiply. So it's going to give you 6 plus y is equal to negative 8. So y is going to be negative 4. Have I answered the question? No. Therefore, P's coordinate is 17 and negative 14. Okay, you guys understand? Any confusion here? Okay. Look at example 3 and this one page. Sorry? 83. Okay, in example 3 on page 83, we are told we are told that P, which is negative 4 and 7, Q, which is 4 and 5, R, which is 0 and negative 1, and S, which is XS and YS, are the vertices of parallelogram. People, if this is a parallelogram, what comes to mind? 4 properties. What are the 4 properties of a parallelogram? Opposite, 2 pieces of opposite sides are equal. 2 pieces of opposite angles are equal. 2 pairs of opposite sides parallel. Did you say that one? No? And diagonals bisect each other. So those 4 properties, they didn't have to put the diagonals bisecting each other. If they had told us this is a parallelogram, then automatically you should have known that the diagonals bisect each other. Okay? Then you are told M is the point of intersection of the diagonals. The question says, determine the coordinates of M, the midpoint of PR. So PR is the midpoint. So how do I work out the midpoint? It's going to be x1 plus x2 over 2. Over 2. y1 plus y2 over 2. Okay. So we're using P, which is negative 4 and 7. And R, which is 0 and negative 1. If that is x1, y1, x2, y2. Okay, so that will be M, x1 is negative 4 plus 0 over 2, which is 7 plus negative 1 over 2. So that gives you negative 2 and 3. Okay, did you all see that? Then in B, they wanted to calculate if M is also the midpoint of QS. You must calculate the coordinates of S. So now, if that is now equal, you should have something like this now. Just distracted here. You got M, which is the midpoint, and we need to calculate an end point. Can you see that, people? So what do? I use now again the midpoint formula, which is x1 plus x2 over 2 is going to give you your x midpoint. Okay? And y1 plus y2 over 2 is equal to the y midpoint. So if this is x1, y1, x mid, y mid, x2, y2. Okay, I'm going with that now. So now we say x plus 4 over 2 is equal to x mid, which is negative 2. And then we have y plus 5 over 2 is equal to? It's equal to what? Now we get 6. It's 3 years. Where you get 6? Okay. So that's over 1. So what do? Cross multiply. So x plus 4 is equal to negative 4. So x is equal to negative 8. Cross multiply here. So it's y plus 5. 3 times 2 is 6. So y is equal to 1. So therefore, S is negative 8 there. Okay. You all okay with that? Then we went into exercise 4.1. Okay, any problems with number 1 in free exercise 4.1? Any problems here, people? You sure? Okay. Exercise 4.1 is on page? Sorry? 84. Okay. So number 1 is fine. Number 2. Calculate the M, the midpoint of line segments joining the following points. Any issues here? You guys do the work?
Yes.
Yes. There are no problems here.
No.
Number 3. Any issues here, people? Number 3. You sure, no? Number 3. Number 4. Here they ask you to prove that AB is equal to BC. So how are you going to prove that AB is equal to BC? Distance formula. What did the length of AB give you?
3 root 10.
3 root 10. 3 root 10, okay? In conclusion, you would conclude that thing. Number 5, any issues here? Okay, so here it asks to calculate P, the midpoint of XY. So what did P give you? XY? 0 and 1.
Oh, sorry.
X, it says X and Y.
20.
0 and negative 1. And then the length of ZP?
2 root 13.
2 root 13. So no issues here?
No.
No. What do you also call that line then? Remember that P is the midpoint. Another word for that line. It's called the median. Make a note there. The median line. Okay? Be a median. People, for these questions, if they give you a diagram, then you sketch it as well. Okay, so that you can draw on the diagram and write all your findings, whatever, on the diagram. Okay, that is why in our answer book we also give you the diagram. Okay, so you guys know this is paper 2, no?
Yes.
4.2, 4.1. Number 6. Any issues here? Okay, so we got ABC, our vertical triangle ABC, that's 90. Determine the length of BC. What's the length of BC?
29.
Root 29. The length of AB?
Root 29.
Root 29. Okay, then you say determine the length of AB. Okay, that's root 29. The area. Area is going to be half base times perpendicular height. Here's your perpendicular height. So one is your base, one is your height. So it's a half times root 29 times root 29, which is going to be 29 over 2. Or 1 and...
Mr. Bodin?
Yes, miss?
Erin Finch, can she come to the office of the banks, please?
No problem, miss.
Thank you.
Alright. You guys understand?
Yes.
Alright. Number 7. Any issues here?
No, sir.
Alright.
Sir, I have a question.
Yes, yes, ask.
You say that like they asked us to do this time. So if I do example, the D, so like I also think that then I forgot to like write the actual course without.
Yeah, you lose 1 more. So you're not answering the question. Who's talking? So you're not answering the question. The question says the coordinates of D. So out of 2 marks, you probably lose 1. But you must have won all your marks. No? Right, the gradient formula. So the gradient formula, MQ, the gradient of MQ is equal to YP minus YQ over XP minus XQ. or y2 minus y1 over x2 minus x1, or yq minus yp over xq minus xp. All the gradients are the same. Okay. In example 1, and example 1 is on page
86.
Example 1 on page 86. Okay. In example 1 on page 86, we are told M, N, P and Q are 4 points in the Cartesian plane. Show that MN is parallel to PQ. What do we note here? Is that two straight lines are parallel if the gradients are equal. So make a note there. If lines are parallel, gradients are equal. But that we knew from grade 10 already. Not so. If lines are perpendicular, what do we know? The product of two gradients is negative 1. If points are collinear, what do we know? The gradients are equal. Not so. So we're working out the gradient of Mn. So it's going to be y2 minus y1 over x2 minus x1. The coordinates of M is 6 and negative 2. The coordinates of N is 3 and 5. That's x1, y1, x2, y2. That would simply give you 5 minus minus 2 over 3 minus 6. So that gives us an answer of 7 over negative 3. You all okay with that? Now let's look at the gradient of PQ. PQ, P's coordinate is 1 and 9, and Q's coordinate is 4 and 2. That's x1, y1, x2, y2. So that would simply be 2 minus 9 over 4 minus 3. So that's going to give you negative 7 over 4 minus 1, sorry, which is now 3. Which is the same. You all agree with that? So we conclude since, state the obvious, since the gradient of Mn is equal to the gradient of PQ, which is equal to negative 7 over 3. Therefore, Mn is parallel to PQ. The gradients are the same. Okay? You all okay with that? Girlfriend, why are you talking? Just look at example 2. Example 2 is on page 86. Same page. Okay, in example 2 we are told if A, B and C are 3 points in the Cartesian plane, show that A, B and C are collinear. What does collinear mean? They lie on the same line. The points lies on the same line, it has the same. You just see that earlier. If points are collinear, gradients are equal. So if points lying on the same line, of course the gradient has to be the same. Okay, you can make that note there. So we work out the gradient of AB and AC or BC. You just work out 2 of the 3 gradients. If the 2 is equal, the third one automatically has to be. You guys understand? So what we do is we work out the gradient of AB. So the gradient of AB is y2 minus y1 over x2 minus x1. So for A, it's going to be negative 1 and 1. B is 2 and 4. Again, if that is x1, y1, x2, y2. It's going to be 4 minus 1 over 2 minus minus 1. So that simply gives us 3 over 3, which is 1. You all okay with that? You guys okay with that? The gradient of AC. Again, y2 minus y1, so it's A, which is negative 1 and 1. C, which is 4 and 6. It's x1, y1, x2, y2. So that's 6 minus 1 over 4 minus minus 1. Which is again 5 over 5, which is 1. Can you see it's the same? So we conclude, since state the obvious, since the gradient of AB is equal to the gradient of AC, which is equal to 1. Therefore, A, B, and C are collinear. You guys understand? Right. Example 3. We know that if lines are perpendicular, the product of the two gradients is -1. Okay. So if PQ is perpendicular to RS, the question says write down the gradient of RS. So we know that the gradient of PQ times the gradient of RS will always be equal to -1, not so? So what's the gradient of PQ? -2/3 times the gradient of RS equals -1. So I divide both sides by -2/3. That cancels. So the gradient of RS works out to be 3/2. Okay? Which is the negative additive inverse of those numbers. People, we'll do number 4 tomorrow. For homework, I would like you guys to do exercise 4.2. Out of exercise 4.2, you should be able to do number 1, number 2, 3, 4, 5, and 6. Alright, so you're going to do numbers 1 to 6 out of exercise 4.2. If you will enjoy the rest of your day, good afternoon class.
Afternoon, sir.